Balance lines. The balance line technique is often associated with the construction industry, where it has gained widespread acceptance as an effective approach to planning and controlling projects with repetitive activities. The method can be considered evolutionary development within the field of project management, incorporating existing ideas and practices to optimize the planning and execution of activities that have repetitive or sequential characteristics. Purpose: balance lines serve to visualize the sequence and alignment of different activities in the project. The objective is to optimize resource allocation and reduce total project time. In the management of civil construction projects, effective implementation begins with methodological assessment, followed by resource training. The critical path method is fundamental, but its applicability intensifies when resource analysis is integrated into recurring tasks. The objective is to minimize the idleness of resources involved in repetitive tasks, considered as a single macro task, with control metrics based on cumulative deliveries. Note 1. To maximize the effectiveness of the critical path method, it is crucial that planning is done without constraints imposed by resource scarcity or suboptimal production practices. Any limitation of these natures can distort the identification of the true critical path and, consequently, the efficiency of the project. Note 2. The combination of CPM and balance lines provides a holistic approach to project management. CPM is strong in identifying critical tasks and time bottlenecks, while balance lines are effective in optimizing resource allocation across repetitive activities. Using both techniques allows project managers to address multifaceted planning and execution challenges more completely. History: the balance line technique is commonly associated with the construction industry, where it is widely used to optimize repetitive activities, such as the construction of multiple floors in a building. However, there is no clear evidence that points to its exclusive origin in this industry. Academic publications, such as the book Construction Project Management Indie Karkar, Chatar, and articles in specialized magazines such as Construction Management and Indie Economics. They highlight its use in construction, but also note its applicability in other sectors such as manufacturing and IT. See article.
Use of balance lines. Lawsuit. 1. Manufacturing. Optimize the production line, minimizing downtime and improving efficiency. 2. Logistics. Assists in optimizing vehicle routing and resource allocation. 3. Gestão. Inventory management used to balance supply and demand, minimizing storage costs. 4. Retail operations. Helps plan store layout and shelf replenishment.
5.
Agricultural production can be used to plan harvests and optimize the use of resources such as water and fertilizers. Projects 1. Civil construction, applied to repetitive activities, such as construction of floors in buildings. 2. IT projects, useful for visualizing dependencies between different tasks or modules in software development. 3.
Desenvolvimento.
Product development, used to plan and optimize the life cycle of new product development. 4.
Pesquisa.
Academic research, used to optimize the sequence of experiments and allocation of resources in laboratories. 5.
Planejamento.
Urban planning can be applied to the development of urban infrastructure such as roads, bridges, and public transport systems.
What you will see here is not a comparison of software features. What you will see here is not from artificial intelligence. I could say what you will see here from natural ignorance. My name is Marcos Pasas, and I will try to transfer the concept to the practical reality of users.
of engineers who use or try to use balance lines in order to reduce costs, idleness, and increase productivity. So, here you see the modeling produced by the manager or construction manager, where he causes the building, in this case it is a building, to be programmed based on some essential or main activities. Preliminary services, infrastructure, superstructure, and then marking, elevation, air conditioning begins. It is the construction of the building until the end called cleaning. Final called cleaning should be at the end. We will not go into the merits of the work plan programming here, but we will focus on the concern that the manager has in reducing anxiety, reducing waste, improving production, or even optimizing resources. This same planning purpose was transferred to another tool. So we have the same needs, the same conditions, but in the first tool we have the time we imagine working, for example, in marking. And the time here is continuous. It starts, for example, in March and ends in August of the same year. Marking in the other tool also starts in March and ends in August, but in this tool you see throttling. Throttling in the bar that represents production. This throttling means no production. There are no producing activities. If you expand looking for the activities, you find the division of the marking into Block 1, Block 2, Underground, Block A, Block B. And if you open Block B, you will then find the producer activities in blue, in the same way as in the other tool. Marking, Block 1B, Block A, Block 2, basement. Opening Block B, you find the first floor, marking Block A. Apparently here I opened both, and here the same thing, Block 1 and Block 2. They are painted yellow precisely to draw attention to the proposed application of the balance line concepts, here in a typical CPM planning. One activity precedes the other precedes a third, and the network establishes a logical production network. It is a production network that is better optimized as early as possible, but still with the condition of doing it, stopping it, doing it again, stopping. Why are there these gaps?
Por que existem essas lacunas?
Because the CPM planning proposal has a logical network and I can only do it as early as possible here and here. So with this I do it as early as possible. There are some gains in terms of risks of delay or rescheduling, but it gives me as a resource manager a problem, which is a team stoppage, assuming of course that the team that schedules is a team other than the team that fixes or a group that does plastering. These are specialized groups. So my proposal here, to apply the balance line, is to see how I can do this technically and without leaving the schedule stuck. Locked means, if I delay or reschedule something that comes before this activity, that activity is consequently moved forward to a new start date. If I make any changes that I break, I freeze this activity. There is a risk in this tool that I reprogram the present. The present has consequences for the future and this activity will be stopped. How to do this while respecting the sequencing logic and giving the schedule the necessary dynamism so that it, even if optimized, reflects the consequences of what happens before its production. So for this I will use two pieces of information, not the beginning and the end. This is calculated. I'm going to use free slack, and I'm going to use total slack, it's total slack, free slack. So I have two important elements here for me to work on this adjustment. But it is also convenient for me to ask which are the predecessor activities of those activities that I want to optimize. So here I already have everything I need in this tool. In the same way, in the other tool I have free play, total play, and let's see the predecessors here.
Predecessores.
Okay, we have the same columns, same fields for us to use, applying a methodology that is part of the line of balance philosophy to ensure better use of teams, reduction of idleness, elimination of stops, mobilization of adequate teams to reduce costs and increase efficiency. Here we have marking, and from what we see on the screen, there are activities of the same type with the same team taking place spaced apart. Some here look like they are close together because the free play is 0 and the total play is 0. So it seems like there's no time off. This one, the last one, has 2 days off. And we have a sequence of work here. And we wanted the sequence to be continuous, without interruption. What is the idea I am going to try to bring here? In principle, the distance between one activity and another is the free slack. How much can it be postponed without disturbing the start of the next one? The problem is that there is not just one connection between the activity and its neighbor. There may be other connections that do not appear in the drawing. So, the strategy of placing the activities that happen before the last one as late as possible and using late as possible, all free slack would be reset and all of them would be placed at the end without disturbing the last one. But here, as we see, the free slack is 0 because there were other connections in other activities in other large packages.
Então,
So I'll have to work with full slack.
se
If there is total slack, it can be pushed into the future. So here I have 26, 19, 26 is the largest number. I could push it to 26 days. But on the way I have 2 here too. And here at the end I have 106. This is really big, so I can push them 26, which is the biggest I have here, and see what happens. How am I going to push her?
não
I'm not going to push you by forcing you to start on the date. I'm going to push you like this. The one before me is activity 6. I'll see if I can find activity 6. I found activity 6 and I will mark it here in yellow. Didactically speaking, it becomes easier.
ela
It starts after this activity, but looking here I have a delay of 5 days of work. So 26 passives of moving into the future plus 5 would be the equivalent of double-clicking 26 plus 5. +26 plus 5 makes 31, I think. What happened? I maintained the precedence logic, increased the delay, which means that if it changes at the beginning, the entire set will suffer along with it. If I hadn't done it by logical connection, if I had gotten stuck, they wouldn't reflect the consequences of the predecessors. But let's see if I solved it.
é total
Total 0, total 2 days here. There are 2 days here. I'm going to enlarge the timescale, scroll, and I'm seeing 2 days here, so 26 plus 2 gives 28. Double click or FTWO on this tool. 31 plus 2 gives 33. The problem is over here.
The problem, I say?
The interruption. Again, zoom in, entire project in this tool. I found everyone working without interruption.
Whereas here,
Everyone working without interruption, although I have the superstructure team here, all together. The team here. No, not that one, sorry. Here we have appointments, everyone works together without a break. Here I have up to 2 days off, I'll check that. Here I have 0. Here I have 0. Here I have 7. The last one I don't change. The last one is that it holds all rescheduled programs like a dam. Here it appears 2 days, 2 days, 2 days, 4 days. I will zoom in to look for idleness. So there were 26, plus 2, that's 28. I'm going to look here where the idleness is. Let's see, there isn't any, it's direct, everyone is direct. So I'm not finding reasons here to let it increase more time here for days. Looking here, I have a sequence. I'm producing the same thing without interruption, until the last one I reschedule. So with this here I was able to optimize the entire project. In the following way, I took total slack from the first and a total slack that I found allowed for motion. Let's do the same reasoning. I'm going to paint them all yellow here. Let's do the same reasoning for another tool. Rescheduled yellow, reddish, dam. The total marking work became shorter, but it was not ignored. It became shorter, so we have 0 idleness. The team works and receives when they work in the activity. The team only receives when they are available. Here we have 100% optimization of team use. Let's move on to another tool. We are in the other tool, and the other tool I already mentioned shows here the product representation bar, strangled at some points, which are precisely the points where there is no work produced. There is existence, but there is no work. Following the same line, I have 0 clearance here, I have free clearance, but I have total clearance here. So who precedes me? It's the 306.
306.
Who is 306?
6.
Code 306. I'll try to locate it here. 306.
306.
I'm going to have to look for this somewhere. 304, 306 is here. 306 using the same logic. Oh, the package has 27 here. The package has a total clearance of 27. I will use the same reasoning. 26 plus 2, 28.
Então vou
So I'm going to get the 306 in this tool, in links, instead of 5 days. It's 5 days plus 28, which gives 33.
três.
28 plus 5, 33. I apply. So, today we see lag, a delay of 23. It doesn't stop the dynamics, and I'm going to try to apply this through calculation.
Vamos
Let's look at the strangulation of the bars. I'm going to zoom in a little more before calculating, so we can see the change. Let's go, calculating.
olhando.
The sequence was, in principle, without any time off between activities, without team idleness. So, we can look here which appointment has more total time off, or there are not 2 days of this activity here.
2 days off completely.
Total is for the purpose of ending the project and not for the purpose of continuity. Here the bar is intact. It no longer has any bottlenecks. I'm going to increase it to day by day.
Dia a dia.
Day to day. Every day off. Oops, there's more. Where's the day to day?
Aqui,
Here it is March 13. Here day by day.
então,
So the first one is here. Scroll. Every day we have work. We have no gap between them. What we achieve in this tool, in the same way, is to eliminate possible idleness or useless stops. So we balance this production line. Not that it is a straight line, a drawn line. Here the reference is production line, production front, production branch. And this reasoning extends to all activities or all repetitive activities that were classified here in the program. I wanted to show this consequence graphically. It's easy in this tool, so that's why I'm going to use this tool. Entire project. We have here a series of graphical information that I will try to detail for you to better understand the concept and the advantage of working this way. I'm going to position it here, increasing the scale to days if you can put it in days again. First activity, in this case the activity that interests you, is rental. So, here, the yellow one. See the graphs. Number of bricklayers on my payroll. Shall we go to the past? Before that, it wasn't necessary to have a bricklayer. But by calculation, in this way of working, I will put it here in days. In this way of working, I have a bricklayer working, a bricklayer not working because it must be a holiday here. These days are not worked. It's a calendar restriction. But observe the number of bricklayers working, and what the bricklayer was like working. Here is the baseline. Before I did this optimization, I had the scenario where blue was bricklayers' hours, and I can go further into the past, and I can go further into the past, where I had bricklayers' hours in blue and green, hours of silly bricklaying. Bricklayer hours available.
níveis.
Green is paid in salary, blue is the reason it exists. So we have more hours available than hours worked. With the optimization we made, eliminating the total slack from the calculation, adding delay, we were able to remove from the baseline what it was, the value of hours, and consequently the value of money that was used for nothing. Let's look now here at the present planning, using the graphic form, which we have here bricklayer per hour. In purple it is lilac, it is the bricklayer actually used, and in light green it is the bricklayer available. Idle released, hours available. Due to the number of bricklayers with all these conditions, in green, of course, free hours, which I represented here below in darker green. And here in lilac, the number of bricklayers, hours of bricklayers who are actually working. increasing, increasing. Here we have 80 hours free for weeks. And here we have 40 hours worked per week. Here we had down here we had I'm going to increase the size of the graph. We had many hours of idle masons working, but remembering that we had a large light green area and a low level of blue sequence of work produced. This way, in the form of hours, not in the form of money. We will also be able to see the money that would be spent before with the money that would be spent now. It will be the same money because the sum of the costs has not changed, but the light green means unused paid wages. Today we have unused paid salaries, there is green, but only from a date, which is the beginning, not in the traditional way given by the CPM, which did not take into account optimization of resources to guarantee optimization of the workforce. In this case, we would be able to do this for all activities that present bottlenecks. Here it is easy to see that elevation appears to have no bottleneck. The activities automatically, as a result of what we did before, are already in optimal shape for elevation. The electrical, hydraulic and IPPCI installations have several segmentations, so all that have this are subject to realignment. In the end, a real schedule is expected with production optimization, optimization of labor utilization, reduction of expenses with rented equipment or available labor in use. Or even the quantity too. We are not analyzing the coherence of this planning here. Because cleanliness, elevators, water tanks, this is cleaning here. Cleaning happens at the end. Elevators, water tank, this year, the landmark, there are several landmarks. And to that end, we are analyzing the quality of the planning and the possibility of optimizing it. In this tool, we would have to look to understand whether balancing is necessary or not. Remembering, balancing the production line means, here, summarizing times, optimizing resources, eliminating idleness and reducing expenses.